3 minutes ago, Webb telescope revealed first ever real image of Oumuamua. Using the Pan-STARRS telescope, a group of scientists made an exciting finding in 2017. They discovered an unusual object which became known as Oumuamua. We've been wrestling with the enigma surrounding its true nature and origins ever since. It's been an enthralling trip for all of us as we seek the truth. In this video, we'll look at an intriguing scientific explanation for the Oumuamua conundrum that has nothing to do with aliens. So let's not waste any time and go right into the fascinating subject. Let us first consider why this object arouses such controversy and sparks such an incredible dispute regarding its origins. When we analyze the strange item known as Oumuamua, it appears that there is an intriguing explanation for its cryptic character. Unfortunately, the only plausible explanation we can come up with is, well, scientific ego. You know, scientists have the desire to be the ones that produce new discoveries in order to be recognized for their exceptional discoveries. The scientific ego frequently causes problems in the scientific community. For starters, it causes the public to lose faith and confidence in scientific discoveries, the scientific community, and scientists in general. Second, this ego-driven culture fosters a competition among scientists to be the first to find something great, which frequently results in errors and even job loss. Let us now turn our attention to an important feature of scientific research: the importance of avoiding hasty conclusions. It's understandable that we're all fascinated by the possibility of extraterrestrial intelligence and the existence of aliens. Many people are convinced that there is life beyond our planet. However, scientists must exercise caution and refrain from permanently attributing a phenomenon to alien intelligence in the absence of solid proof. Jumping to conclusions without examining other logical answers can be viewed as reckless, especially among scientists. While non-scientists can speculate, scientists must adhere to scientific principles. When investigating assertions, it is critical to approach hypotheses with skepticism and avoid treating them as proven fact too soon. Unfortunately, this has happened in a number of cases in recent decades, notably the situation of Planet 9. Nonetheless, despite these difficulties, discussing Oumuamua is still worthwhile because there is new work that is great and highly interesting to read. But first, let's talk about Oumuamua's shape, because the depictions you've seen thus far is this odd cigar-like shape. Many scientists, however, do not believe it was the shape of it at all. In reality, some recent studies imply that the shape is more akin to a flat pancake or a long used bar of soap. This analogy is actually pretty significant, as we'll explain in a moment. Unfortunately, we're trapped with this shape for our illustrations because all past depictions have used it. But first, let's look at the intriguing features of this object. Scientists determined that it entered our solar system at a slower rate than we would expect from an interstellar object. This indicates that it had not been in interstellar space for an extended amount of time. In fact, analysts believe the interplanetary journey lasted no more than 500 million years, perhaps even less. It is thought to have first entered our solar system's outer reaches around 1605 during the early days of astronomy. It is expected to leave our solar system in the year 2430, traveling at a constant speed of around 26.3 kilometers per second. One of the more unusual features of this object is its light curve. The random swings in brightness were interpreted by scientists as the object tumbling as it traveled through the solar system. The actual shape of the object, however, has been a source of contention. It was initially thought to resemble a cigar shape, but additional research led experts to determine that it was most likely disc-shaped. Nevertheless, nothing about this object has seemed out of the norm so far. However, while astronomers attentively followed Oumuamua's departure from our solar system, an unexpected event occurred. They found a minor difference between the observed orbit and the predicted trajectory. While such deviations are usual for comets, which fluctuate in orbit and trajectory due to material emitted from their cores, Oumuamua lacks the typical cometary tail that accompanies such shifts. This confusing observation suggests that the trajectory was actually altered, despite the absence of a cometary tail. This oddity prompted the development of the following hypothesis. And guess what? Scientifically, the whole concept of this unusual item is still a little perplexing. There are various additional hypotheses that appear to make a lot more sense. In reality, there are numerous articles on this issue. These documents provide what many experts believe to be. Here are the best explanations we have right now. Let's look at the key points raised in the two most fascinating publications. To begin, one of the assumptions made was that the enigmatic object had a pancake-like shape. It wasn't your typical spherical comet. The second explanation is related to the color and composition of the thing. This object you see was not made of the same material as the comets we normally detect, such as the renowned Neowise comet. These comets are mostly made up of frozen gases, such as various types of water ice, methane, carbon monoxide, carbon dioxide, and ammonia. When these gases react with sunlight, they emit unique colors that we can see from afar. But now comes the intriguing part. We also know that countless objects lurk on the outskirts of our solar system. Consider the magnificent Pluto. It is in the same neighborhood as other things with distinct compositions. Pluto and other objects have a reddish tint because they contain nitrogen ice. That lovely reddish color on Pluto's surface is, of course, nitrogen ice. And the manner in which this nitrogen ice evaporates differs greatly from that of a regular comet stuff. So, according to the scientists behind these studies, this puzzling object was more likely a bit of nitrogen gas. They think it came from a faraway Pluto-like object in another solar system. In other words, it's a piece of an exoplanetary Pluto, or possibly an exodwarf planet. Consider it a little bit of another universe drifting through space. This concept is wonderfully captured by the explanation offered in this illustration. Let us now go into this intriguing cosmic story that began 400 to 500 million years ago. Consider this. A far-off Pluto-like object collides with an unknown creature in another star system. As a result, a massive chunk breaks off and travels to the star system's outskirts, eventually ending up in interstellar space. This chunk was most likely more round in shape at first. The passage of time, combined with the interaction of nitrogen and cosmic rays, caused it to progressively erode, similar to how a bar of soap flattens with each use in your bathroom. You've probably seen this before, as you lather up the soap and see it gradually morph into a thin, pancake-like shape. A similar thing happened to our celestial explorer. In 2017, the chunk enters our solar system, approaching its closest point to the Sun. It then continues its voyage, leaving the solar system behind. We were only able to discover it via telescopic observations a few months later. The orbital irregularities were most likely caused by nitrogen ice evaporating from its surface. Surprisingly, when nitrogen evaporates, it does not produce the typical tails that we associate with such processes. As a result, we would not have been able to discover the object at issue without the evaporation process. Consider the consequences of this revelation now. Because the ice fragment came from another dwarf planet, it is plausible to believe that it was far more reflective than expected. As a result, the object's size was most likely smaller than our first estimates. This reduced size, combined with large emissions from nitrogen evaporation, resulted in a more dramatic divergence in its orbit than projected. In essence, while spewing large amounts of nitrogen, the reflective ice piece gives a credible explanation for the observed changes in its orbital behavior. Indeed, this hypothesis fits nicely with all the previous facts. Even the object's reflectance is similar to that of other celestial bodies discovered, such as Pluto and Triton. So, it's basically a large part of a dwarf planet, or some kind of junk from another star system. It's remarkable since it originated from the same location where dwarf planets are typically found. These two items most likely came from a newborn star system that was still forming, just like our own solar system was in its early beginnings. There were a lot of collisions going on at that time, which is probably why this object was ejected in the first place. This study demonstrates that other star systems have dwarf planets made of comparable materials to Pluto, Triton, and several other outer solar system dwarf planets. It's fascinating to consider how these objects arise in different star systems. What's more, recent estimates indicate that approximately 7 such objects pass through our solar system each year. This implies we have a tremendous opportunity to find and study more of these things in detail before they vanish. Consider how much information we can learn from researching interplanetary visitors. Regardless of the controversy and varied viewpoints surrounding this object, there's no disputing that it is one of the most remarkable finds of the last decade. Scientists will undoubtedly debate and analyze it for years to come. These kinds of discoveries stretch the frontiers of our understanding and pique our interest in the enormous universe we live in.